Let's do a couple more dimension drawings of our VEX parts. I'm going to do a dimension drawing of the shaft here. I know it's 4 inches long because I have to choose that when I put it into the assembly, but let's go ahead and do that. So let's go with the size A. And what you'll see is that the front view is going to be this one, which is the shaft edge on, which is not what we want. We want the front view to be the most representative view of this part, and that is certainly not the unit edge on. So I had to go in here and change the scale because Onshape had dramatically increased it because it thought it was putting the other view in. You would think it would be smart enough once I changed to say the right view away from the front view on the part and the right view in the here, but it doesn't. Okay, so here's our front view. So let's left click here and we'll put the right view here, and finally the isometric, and we'll show that shaded view. Now these are quite small, so let's do the following. Let's of course get the length here. It says 3.98. I think that's because of the chamfers. Let's put a really the whole thing needs to be blown up. Let's, on the right view, let's make it 4:1. How about that? So this is what it looks like when it's blown up. It's still, there's a lot of features we can't really see easily. We need to really zoom up. So let's at least get the size of this thing, and we find out that it is 1/8 of an inch. And we'll come here like so. And I prefer, I don't know why it just doesn't put it below it. That's okay, whatever. All right, and I guess this circle could be of interest. This is a circle which kind of defines the way the way the chamfers are made. Let's put it over here like so. And then finally, we're going to get out the chamfer, and actually we're going to know, I guess it's not a chamfer. Right there. Okay, let's go back to a regular dimension. And how does that work? I guess we don't really need to know the details about that. So what do we have? We have the length, about 4 inches. We have the size. I guess the 0.125s are the key things we want to know. Otherwise, the other stuff is not all that useful. But we'll take it. So we'll end there with the shaft. Let's do one more, and it's a complicated one. Let's do the gear, the 36 tooth gear, and I'm going to choose the C. And actually, what we're going to see is that, okay, it's going to be put into the drawing with the correct front view because it's oriented with the front view, looking at it this way. So let's go ahead and do that. And again, let's use a size C piece of paper. And okay, it makes it twice as big. That's fine. So there it is. And then on edge, looks like that. And then isometric, it looks like this. And what might we want to know about this? Well, I think we probably want to know some of the, like the diameter of this thing. But if we come here and we put, say, the diameter there, we're going to get a radius. So the diameter is going to be twice that, roughly. We need that if we need to make some sort of relationship between the gear and other gears. We need to know the number of teeth and sometimes the diameter. So there we have it. Okay. How about the size of the opening here, the square one? Well, it better be about that value. Okay, so we know that the shaft is 0.125, so this is 0.127. That makes sense. And I think, I mean, we could just, we know that what this is going to be. It's going to be that distance, okay, or that amount. It's a square. What else do we need to know? Maybe the total thickness at various areas. Probably here. So it's 1/4 inch width of the teeth. And there's been times where I wanted to know this distance. So that is a 1/16 of an inch, 0.063. And again, on this one, I think we can write over here space TYP. So the other one's going to be that as well. All right. We have that. Okay, so we've got all this real estate here in this enormous piece of size C paper. Let's take a look at the teeth. So let's do a detail view right here. like so. And let's make it much bigger than that. Let's get a little crazy here and take a look at the size of these teeth. Can we go even bigger? What is the next one's 10 to 1? Let's do that. Okay, so those are our teeth. And what might we want to know? Well, um, can we go, say, from here to here and get the height of those teeth? These are two concentric circles. What if we did this from here and then also, I think, that one? Okay, so we can kind of understand the height of the teeth. So it's about what? 792 minus 708, or 84.084. Okay, fair enough. And we can come here and get the size of this one as 14 thou. And this is an interesting one. So that's got a radius of 116 thou. We might not need all this stuff, probably don't. But we can at least get some idea of what's going on. So probably the useful stuff here is this radius, which we really want the diameter. And I think there's a way, I've forgotten how to do it, to put the to put a circle around there. We're going to hold off on that. So, and we have the thickness. We know it's a 1/4 inch. So if we wanted to have a stronger gear, we might want that to be bigger or wider, more than a 1/4 inch wide. And these little things jut up 0.063. So that's some good information to have for our gear. We know that we can look to the radius here to find the diameter, which will allow us to find the circumference, which we need if we're going to make a rack and pinion mate relation in Onshape. So I think that'll do it for this one. Thanks for watching.